Hey there, class. Sorry I'm not here with you today, but hopefully this video is helpful for understanding the concepts and mastering them. So today we are talking about two different ideas. One of them is the Pythagorean theorem, which you have been exposed to in the past, and the second one is the midpoint formula, which you may not have been exposed to, but is also fairly intuitive. So let's go ahead and begin. Let's mark this guy up here. And let's start with this fun problem here. So we're looking at this figure, and without using the Pythagorean theorem, we're going to find the area of the inscribed square. So this is the inscribed square. So we got to find the area of that. Well, one way of doing that is finding the area of the large square, the blue square, and subtracting away from that the area of these four little triangles. Well, if I took those four little triangles, let's color these guys in green. They're 4 by 3, right? So this guy is 4 by 3. Now, if I was to connect this one with this one in that corner, right? If I was to connect these two together, then I end up with a rectangle. And now the area of that is 12, and I could do the same thing with the other two. And the area on these ones is also going to be 4 by 3, also going to be 12. So 12 plus 12 is equal to 24. So the area of the big square, let's talk about this. The blue square, this is 3 and 4. So this is 7, 4 and 3, 7. So it's 49. We're subtracting away from there the area of those green triangles, 24. And from this, we get the area of the red square in the middle, which is 25. So we have found the area of this is 25, and now because it's a square, the side lengths have to be 5, right? Because 5 times 5 is 25. And so we've basically found the length of this triangle that we didn't know. We know it was 3 and 4, and now we know 5. So this is kind of one way that you can prove the Pythagorean theorem. Let's go ahead and do that now with this thing. So let's go, hang on, done. Let's go and now prove this in the general case. And right now what we're doing is we are deriving the formula for the quadratic equation. So we're going to use the same colors. The big square is how long? Well, it's a plus b long, right? This whole length is a plus b. How tall is it? Well, it's a plus b tall. So the area is height plus width. Now we're going to FOIL this out. A times a is a squared plus ab plus another ab plus b squared. So the total area of the blue square is a squared plus 2ab plus b squared. What we're trying to find is this length right here, c. So what's the relationship between a, b, and c? Okay, well, I am going to subtract away from this the area of these green triangles. Now, these green triangles are a tall, b wide, and we're going to do 1/2 a times b, base times width, and there's 4 of them, multiply that by 4. Now, when we clean that up and the dust settles, we have the combined area of all the green triangles is 2ab. And that, my friends, is going to equal the area of the inscribed square. Okay, one more time. Just for, the conceptual idea here is the blue square. We're taking the blue square. The area of the blue square is a squared plus 2ab plus b squared. Now we're subtracting from that these 4 triangles. Their combined area is 2ab, and that's going to equal c squared. Well, we can do a little bit of simplification. Let me circle 2ab minus 2ab. Those cancel out, and we are left with the beautiful and elegant formula a squared plus b squared equals c squared. That's the Pythagorean theorem, which we know and love. And let's go ahead and just do a couple questions with the Pythagorean theorem just to make sure we know how to use this guy. So let's say we have something like this, and this is 6 and 8, and we want to find out h. Okay, so legs squared plus other leg squared is equal to h squared. So 6 times 6 is 36, 8 times 8 is 64. Oh, sorry, I meant to do equals. All right, equals h squared, that's 100, equals h squared, take the square root, 10 equals h. All right, so equals 10. Now, most of the time you use the Pythagorean theorem, you're not going to get even numbers, right? It's going to be something like 1 and 7, and we're going to call that h. And so 1 squared plus 7 squared equals h squared, and 1 plus 49 equals h squared. So 50 equals h squared. So 5 square roots of 2 is equal to h. And I did a little fancy square root simplification in my head, but you followed that, right? Okay, now let's do this one, and don't get confused. I'm going to draw this like this, and we're going to say this is 7, and this is 10, and this is h. Now, I did this intentionally to confuse you. What you have to remember for the Pythagorean theorem is it's leg squared plus leg squared is equal to hypotenuse squared. How do you find the hypotenuse? It's the length directly opposite that right angle. So we're going to write this now as 7 squared plus 8 squared is equal to 10 squared. So don't let that confuse you. You got to remember, leg squared plus leg squared is equal to hypotenuse. Hypotenuse is the longest side, it's opposite the right angle. So 49 plus 8 squared is equal to 100. We're subtracting 49 from both sides, and we get 8 squared equals 51. And so 8 is going to be the square root of 51. So this leg, we've solved for that leg and found that it has to be the square root of 51. Okay, that's it for the Pythagorean theorem. Now let's go back to our notes and finish up these guys. We're now going to talk briefly about the midpoint theorem. And you can see the notes here are exceptionally short because this concept is exceptionally intuitive. And we'll talk about this. Let me zoom in here a little bit. On a number line, how do you find a point exactly between -6 and +10? So let's draw that number line. Here we've got -6. And over here we've got +10. And I could just kind of step 1 here, step 1 there, step 1 here, step 1 there, and eventually I'd find that middle point. Now there's of course a much faster way of doing this, which is just taking the average. The average is the point in between the two extremes. So -6 plus 10 divided by 2 is going to equal 2. And so that midpoint is going to be 2. And that makes sense because from 2 to 10 is 8. And from -6 to 2, it's also 8. So it's 8 in either direction. Now, the midpoint formula is just taking that same idea and extending it into 2 dimensions. So what if we wanted to find the midpoint between, I don't know, let me do some different numbers. Let's say the midpoint between 1, 6, and let's do 9, let's do 2. Okay, so we want to find the midpoint between these. So it's somewhere here. Well, if I kind of go down here, this point is 1. If I go down here, this point is 9. And I need to find the point exactly between 1 and 9. So I think 1 plus 9 divided by 2 is going to be 5. And so in between is 5. And again, that makes sense because from here to here is 4. And from here to here is also 4. So 5 is in between. And so this point is going to be 5, something. Well, I can do the same thing now looking at the y values. This y value is 2. This y value is 6. So it's something between 2 and 6. 2 plus 6 is 8. Divided by 2 is 4. And 4 is right smack dab in between 2 and 6. So this point is going to be 5, 6. Okay. And so, 5, 4 is what I meant to say. Okay, and that makes sense because I have 2, 4, 6, and here I have 1, 5, 9, and it's just right in the middle. Now there is a formal formula for this, and it looks really complicated, right? This just looks abominable, but really you're just taking the average of the x values, the average of the y values. And let's just, for fun, zip over here to Desmos just to show you this, just to prove this to you, make you happy that it works all the time. And let's pick a couple of points here. So let's do the point 1, comma 5. And right here, let's do the point 5, comma 7. Okay, so we got those 2 points, and we want to find the midpoint. So I take the average of 1 and 5. 1 plus 5 is 6, divided by 2 is 3. If I can reach 3. Come on, give me. Move over. Move over, little guy. There you go. There you go. That's a good place for you. Okay, 3, comma 7 plus 5 is 12, divided by 2 is 6. And if you look, that green point looks exactly smack dab in the middle of the red dot and the blue dot. And that's it, guys. Hope you have a good day. The substitute should already have announced the plan is to work on the test review. There is no homework for this lesson. It's just going to be wrapped up in the review.